All right, today we're talking about proportional versus non-proportional. We talked about proportions being equivalent fractions, equivalent ratios. So obviously non-proportional is non-equivalent, not equal, okay? Proportional means that something has a constant rate. This is super important. Probably about 2/3 of your test deals with this constant rate idea. Constant rate. Proportional means constant. So non-proportional means it's not constant. It's changing. Okay? Proportional is constant. Non-proportional, you don't have to write out the whole word again, means not constant. Can someone raise their hand and give me an example of something they think would be a proportional or constant rate in the real world? Yeah. A what? A repeating number, maybe, yeah. Anything else? Constant rate, yeah.
Do you mean like a price that stays the same?
Could be a price that stays the same, like price per pound or something. Anything else that would be a constant rate? Yeah?
Your age.
Your age?
Yes.
Yeah, no matter what you do, you're aging every day.
Yes.
Anything else, like constant? Yeah? The what? Say it really loud. The Earth spinning is pretty constant, right? If it changed its rate, what would happen? We might fall off the Earth. Who knows? What else?
Wall Street.
Wall Street is an example of non-proportional.
It is.
It goes up and down. Yeah.
The seasons.
The seasons, good. When I actually started running, if I run like once every 5 years, I'll run on a treadmill so that I can set my constant rate, my super fast rate of 12 minute mile. And that would be constant. But if I ran on the street, you know, I'm running and I'm really clumsy and I trip and fall, now I've stopped running and have to start over, that would be not constant. Did you have an example, Zach?
Your heartbeat.
Heartbeat should be constant. However, if you exercise, what happens?
Goes faster.
Faster. And then when you're sleeping, what happens normally?
Goes slower.
Goes slower. What else?
Evaporation.
Evaporation could be either one. Okay, moving on. Good examples. Thank you, guys. Shh. Example 1. Are these rates proportional? I'm going to give you 2 rates, and you tell me, are they proportional? Oh, actually, I'm giving you 4. I forgot. 4 different rates. Rates can be fractions or ratios. Think rate, ratio, fraction. Are these proportional?
I don't understand what you mean by constant.
Well, we'll find out in just a moment. Raise your hand if you think they're proportional. Raise your hand if you don't think they are. They look very different. Raise your hand if you have no idea.
All the time.
Well, the first one I see, 18 over 1, that's a unit rate, right? It's over 1?
Oh, no.
So if I could get everything to match that, would that prove that they're constant and they're proportional?
Yeah.
So if I divide 36 by 2, what do I get?
18 over 1.
Wow, I get 18 over 1.
Fractions.
If I get 54 divided by 3, what do I get?
18.
18 over 1. 72 divided by 4? So yes, because all ratios can be simplified to 18 over 1. This would be constant. It's constantly changing 18 for every 1. 18 for every 1. So, proportional, constant. All of these he's saying is that just means that you're going to get the same ratio every time. And to figure it out, we have to get down to the unit rate and put it over 1. Let's look at this one, example 2. Oh, actually, we're going to look in the book. So look at your book on page 36. We're going to look at 1 and 2. What? I didn't want you to have to write this down, but keep your notes out. But if you look in your book, if you want to just write in your notes like where to find this, it's page 36, 1 and 2. It's under the guided practice. I'm going to do these with you. Does everyone have this written down up here though? You can put the book under. Okay. So we're going to look at 36. It looks like this. You can see that it's much easier to do here than to actually write these out in your notebook, right? And remember, the next quiz is going to be open note, open book. So you really want to make sure you're writing these examples in your book. Okay, it says, actually, does someone want to read it?
Me.
Okay, Israel, go ahead and read it because you're near the microphone, so go ahead. Number 1.
The Vista Marina rents boats for $25 per hour. In addition to the rent fee, there is a $12 charge for fuel. Use the table to determine if the number of hours you rent the boat is proportional to the cost, to the total cost explained.
Okay, so circle the $25 per hour. Circle that. And then it says, in addition to the rental fee, there's a $12 charge for fuel. So circle the $12 charge for fuel. And then it says we have to use this table to determine if the number of hours you rent the boat is proportional to the total cost. So first, let's just try to fill in the table. Okay, so let's start with rental time in hours. Let's do 1, 2, and 3. So put 1, 2, and 3. Okay, now let's look at the cost. If we rent the boat for 1 hour, how much does it cost? $25 plus the 12, so that's 37, isn't it? You see that? What if we rent it for 2 hours? We're up to 50 plus the 12. So that's 62. The 12 doesn't change, okay? And after 3 hours, now we're 75 plus 12, so that's 87. You were close. 87. Now, we need to figure out, is it proportional? Is this rate constant? Why is it not constant? Someone raise your hand and tell me, why is it not? You're right when you say no. But why is it not, Nolan? Okay, good. The fuel stays the same, right? So if that's not increasing, then this is not increasing at the same amount, correct? Another thing that you could do is you could divide 62 by 2, and what do you get? 31. And that one's 37, right? You can already see those are not the same. So you would write no. The ratios are not equal. Do that symbol. It's easier, right? Let's try another one just to make sure you guys get it. Number 2. Yeah, you want to read it? Okay, go ahead and read number 2 nice and loud. Good. Go, keep going.
What situation represents a proportional relationship between the hours worked and the amount earned for Matt and Jane? Explain.
Okay, so we have Matt and we have Jane, and they're working, right? It says they've worked, each of them, it looks like, has worked 3 hours, and then we know how much they made after each hour. Do you guys see that? Okay, and they say which one is proportional? Which one is proportional? So of the 2, you guys already know the answer? Yeah. Wow. Okay, raise your hand if you think Matt's is proportional. Raise your hand if you think Jane's is proportional. Raise your hand if you don't know why they know that already. Okay, some people did that really fast. But let's just look at Matt. Do you see how it's changing 12 here? $12 an hour. Then what happens here? What's this change? How much is that going up? 12 to 20 is not 6. What is it? 8. How about from 20 to 31? What is that? 11. Is that constant? No, because these are all going up by 1, but this is not. Let's look at Jane's. What's hers doing here?
Going up by 12.
And then what's it doing here?
Going up by 12.
Good. So you would say Jane. Jane's ratio, we'll just put Jane's ratio is constant at 12. That'd be good enough. It's always changing by 12. For some reason, Matt's making more depending on the hours. It's changing. It's different. I don't know what's going on with Matt's earning. Maybe Matt's on commission.
No.
He doesn't have a constant income.
It probably works like 1 hour.
Yeah.
$8. And then
Right. Or he
11 hours,
sells something and sometimes it's cheaper here or there, right? Who knows?
it probably works.
Okay, so those 2 examples are going to help us do the rest of the work later. Okay, the next thing I want you guys to do is to go back to your notebook. So just put your math book to the side. Okay, and we need to look at graphing. A lot of people get confused by tables, but when they see the graph, all of a sudden they get it. So I like to put these 2 together. Okay, so write 3-4 graphing. Okay, so when we're graphing proportions, we kind of remember graphing, I think, a little bit, but some things that we forget is this thing, the coordinate plane. We need to recall. So I want you to draw this little picture in your notebook just to recall, okay? So basically draw your y-axis, your x. The center is called the origin. We want to label all these things. Do you guys remember the quadrants? Quadrant 1, and then it kind of goes counterclockwise, 2, 3, 4. So before we can graph anything, we just need to remember how do we graph, right? We have our x's and our y's. A lot of people, when they go back to graphing, they graph their points wrong because they're graphing their y then their x. So that's why we're just recalling how to do this. Okay, and then if you're graphing like x, y, those are called ordered pairs. Do you remember that too?
Yeah.
So you can write that down. Did you guys start doing this in 6th grade or before that? Fourth? Third, fourth, and fifth even? So you've had a lot of practice, but who really can say honestly they remember this 100%? Okay, so maybe half of you. So again, when we're graphing ordered pairs, we get this point x, y. We always go to x, and then we count to y, right? X first. Okay. So graph x, then y. We do that every time. When we're graphing proportions, we're pretty much going to deal with the positives. So if we're only dealing with the positives, what quadrant is that? You can say it all out. 1. All the positive x, all the positive y, we're dealing with 1. Okay? Here's why we're dealing with here's why we're dealing with quadrant 1 and the positives mostly. There's a couple exceptions. But most of the time we're graphing some sort of rate Like it goes up this much per hour, you get paid this much per hour, you're driving this fast per hour. Those would be positive rates. Now, if you were, say, like losing money, then that would go into the negative, right? But most of the time, we're going to graph the positive quadrant 1. So you don't have to worry as much about negatives in this unit. Okay. So for the examples for this one, once you're finished writing that down, go to page 48. We're done with that.
What's integer quiz C?
It's a quiz. Okay, so page 48. Are we ready? Most people got that written down okay? Okay. Page 48, let's first look at number 1. Does someone want to read that one? It's about the 3D movie tickets. You want to read it, Paul Veer? Okay, make sure you guys are nice and quiet. Listen to Paul Veer.
The cost of 3D movie tickets costs 12 for 1 ticket, 24 for 2 tickets, and 36 for 3 tickets. Determine whether the cost is proportional to the number of tickets by graphing on the coordinate point. Explain your reasoning.
Okay, let's circle stuff. Thank you. So the cost of a 3D movie ticket is 12 for 1, so circle that. Then 24 for 2 and 36 for 3. Do you think that's going to be proportional even before you graph it? Can you see that? It's $12 each time, right? But we have to figure out if it's proportional. We say yes, but we have to show it by graphing, okay? So let's look at this one. So here's my tickets. I have 1, 2, or 3 options, right? How much for 1 ticket?
12.
Okay, so go over to 1 and go up to 12 and put a dot. You see that? 1 ticket is $12. Now 2 tickets. How much for 2? 24. So go over to 2 and go up to the 24 and put another dot. How much for 3?
$36.
Okay, so we go over to 3, go up to the 36 and put another dot. Now for these small graphs, you don't really need like a ruler, but when we get to bigger graphs, you can use rulers and stuff. But let's go ahead and connect the dots. Should make a straight line, right? Now, how much for 0 tickets? $0, right? So go ahead and put a dot there on the origin and keep connecting your dots. This is important. For a graph to be proportional or something to be proportional, it always has to go through the origin. So it would have to start at 0, 0 or go through 0, 0. So make sure you always connect all the way down to 0, 0. So we would say yes, this is proportional because, and this is all you would have to say on your quiz and your test, so easy, because the graph, you're going to find yourself repeating this a lot on your homework, is a straight line through the what? Through the, what's this called? 0, 0? Origin. So if it's a constant rate, if it's a proportion, you will have a straight line going through the origin. If it's not, what will your line look like? Maybe zigzagged, it won't go through the origin. It could be a straight line but not going through the origin. That could be non-proportional. Let's look at number 2. I'll read this one. The number of books 2 stores sells after 1, 2, and 3 days is shown. Which book sale represents a proportional relationship between time and books? It's pretty obvious. Which one's the straight line, guys? Book Palace. So let's write the Book Palace. Explain Because, what do you think I'm going to write?
Straight line.
Because the graph is a straight line, I'm going to abbreviate, okay? Because straight line through the what? Through the origin. All right, number 3. This is the essential question. How does graphing relationships help you determine whether the relationship is proportional or not? How does graphing help us? How does graphing help us? What do you think?
Because if the line's straight and goes through the origin, that means it's constant, and it'll go up and
Yeah.
it'll go up, and then
Perfect.
if it isn't, then
Yeah. Great. So basically what we just said. So the graph will be a straight line going through the origin. Does anyone feel like we repeated ourselves? You should feel like that. So when you get that question on your test and it says, how do you know it's proportional after you graph it? That is your answer. You don't have to say anything else and you'll get it right. Yeah.
You know, I have a question about that book palace thing.
Yes?
I don't think they make the employees make a lot of money because they're selling 9 books in 3 days.
Yeah, maybe not.
Just
Maybe
3
they're
books a day.
antique books and they make, who knows.
I don't think they're books.
But yeah, you're right. It's not very, not a very good margin there. Okay. Any questions other than about the book palace, the employees? All right.